This video is about cybernetics, the enigmatic science. Cybernetics revolutionized the world of knowledge. The key idea was feedback, which was not present in the cause-effect paradigm of traditional science. Feedback had just helped win Second World War when cybernetics was born, and it went global. It defined information and the role of communication and control in any purposeful system. Yes, cybernetics created the Big Bang of the information age, and then it disappeared. There are several reasons why this happened. Number one, I would say that computers stole the show, and computers monopolized the prefix cyber to mean anything related to computers, not to cybernetics. Computers were exciting, programmable, and they could do the work of thousands and thousands of human computers. Reason number two, academia rewards the creation of new sciences. So it turned out that the branches overshadowed the trunk of the tree, which was cybernetics. You have other sciences popping out, such as artificial intelligence, computer science, informatics, complexity science, and the science of chaos, among many others, because you also have a special kind of psychology, you have neuroscience. All these sciences can be linked to the common trunk called cybernetics. All these sciences got their own spotlight, and cybernetics was displaced. All these sciences try to find themselves their own roots, different from cybernetics. However, I think that none of those sciences can really walk away from the definition of cybernetics provided by Ross Ashby. I have made a composite of his definitions into one that I will tell you about. According to Ashby, cybernetics is a high-level language for ordering, relating, and understanding all possible machines imaginable and their behaviors, as long as those behaviors are repeatable, regular, determinate, and reproducible. Now, how can you escape that definition of cybernetics? It covers everything that's going on. Everything that is going on in the world is the product of some sort of machine, whether simple or complex or complicated. In fact, all of science has always been interested in understanding phenomena that are repeatable. Why? Because repetition leads to finding out about control. If something is repeatable, then you can learn how to control it. Now, Ashby's definition of system helped create second-order cybernetics. And second-order cybernetics distracted attention from the original cybernetics. But here is the reason why. Ashby defined a system as a list of variables that map to a single value transformation. What this means is that the observer is the person defining the system. It is the person that identifies this list of variables and has the burden of proof on showing how these variables are connected into a system, into a whole that has some meaning. Now, these variables will act as a unit, and this is what makes them a system. But it is up to the observer to point out to this relationship, to this interconnections. So this is why I have also called cybernetics the science of interconnectedness, because without the interconnections, you don't have a system. You never get a system without interactions. A system is a collection of parts that produce an emergent behavior. And talking about the observer as the person that decides what the system is, helped create second-order cybernetics. Second-order cybernetics is about the observer looking at a system where some other observer is doing something. So Ashby's definition helped create second-order cybernetics. Now, Stafford's Beard Conference in 1990, called the Intelligent Organization, was the final proof that cybernetics created a new paradigm for gaining knowledge, very different from the traditional cause-effect paradigm of Newtonian science. So you have the Newtonian science paradigm and you have the cybernetic paradigm, where knowledge is, as I said, the product of some observer making an observation about a system that he has identified. So there is some subjectiveness to cybernetics, but it allows us to gain knowledge where traditional science is totally ineffective, such as the phenomena of life. This is the importance of cybernetics. Cybernetics can explain life, but traditional science cannot explain life. There's a fifth reason why I think that cybernetics was vanished. Stafford Beer in Chile tried to create a new way of governing a nation. Management cybernetics is more associated to a cooperative kind of management and not a competitive style of management. All these 5 reasons have led to the isolation of cybernetics from government circles, academic circles, and business circles. However, as this ostracism of cybernetics has been taking place, the world has become steadily more and more complex. So I am trusting that cybernetics, and especially management cybernetics, will make a big comeback very soon. The world is very badly managed at every level, and we need a better understanding on how complexity and cybernetic systems have the solution for many of our problems. Cybernetics is the proper language to deal with matters of governance. In fact, the word governance comes from cybernetics. If you want to learn more, I suggest that you get my book, Kubernetes, Universal Governance and Management. It is available on Apple iBooks. Thank you.